Okay, API security without going around in circles. But first, I wanted to tell a story that my wife and kids are going to be very upset at me for telling. So, in this conference, we try and solve the big problems. We want to make the most impact on the most of society. I'm making this up. And then, everything will be secure. And something that really impacted me recently was when I looked into my underwear drawer and saw this. Now, I've redacted a few bits for the innocent, but any anal retentive dad will tell you 8 unmatched socks is unacceptable. So what can we do about this? There's a problem with single socks in society. They're trying to find people, but they're involuntarily solely single, and we need to help them. So what can we do about this? Well, of course, any problem needs to have an IT solution, and any IT solution needs to have a logo and a domain name. So I'm introducing to you Soccer. Find your soulmate, and you'll find it at the website soccer.net, which is actually like a double pun, so it's even better. And if you go on there, if you're feeling lonely, if you're a holy sock and you want to look for other holy socks, if you're a left sock seeking right socks, if you're ambidextrous, come along to soccer.net and find your soul mate. So, what is soccer.net? Well, let's do a really important demo. Okay, so this is the website. It's a demonstration of how bad I am at programming, but also of using a GraphQL API from a client-side JavaScript. So this is the site. Basically, it's a dating site. It looks very familiar. If you're on the New Zealand dating scene, I'm told that there is a website very similar to this, but unfortunately I was married before websites, so I haven't actually logged into that one. And you can choose your preferences, whether you want people with holes, socks with holes, which part of New Zealand you'd like to meet, and then you can search single socks in your area. Now would be a really good time for some audience interaction. So please have a look around for you and see if you can find any single socks. Oh, okay. Is this on? Okay, hold up your socks if you've managed to find some. Okay, this is pretty hectic, so I think that's enough sock looking. Hold up your socks, look around. You can find your soulmate and also some chocolate. And I promise the socks haven't been worn, so this chocolate is still safe to eat. So yeah, that was crazy audience interaction. Check. Cool. What else can you do on the site? Maybe I should use this mic if you want. Then I don't have to hold one. Is that one on? Okay. Okay, I'll type one-handed. So when you're not logged in, you can go in and look at the details of a sock and see what they're interested in, a little bit about them, some photos. There's some information about the sock itself and also a listing where it advertises itself. Once you log into the site, then you can click on socks and say that you're interested in them. And if they're also interested in you, then you'll be a match. and more information will show up on the site. So here's some private information that I couldn't see before, and now we can do sock stuff together. Cool, I am really hoping I don't get complaints. I'm trying to stay left of the line. So yeah, that's the sock website. You wouldn't believe how many hours of work it was for that really lame joke. Okay, so here's the architecture of the website. So which one's live now? The desk mic? This one still? Can I switch? Okay. This one? Yeah, cool. So here's the architecture of the site. Pretty much everything runs in the browser. So while there is a web server, it just basically gives JavaScript, React magic. The browser then sends requests to GraphQL. GraphQL proxies them to a REST API, which sends them to and from a database. So pretty simple architecture. One thing to note is we're doing auth in the GraphQL layer, so we're checking that there's a valid user and role checks at that layer, but you might see authorization done down at your API pros and cons. So APIs, why does API security matter? So we've had a couple of talks already, but I don't think anyone's gone in depth into the OWASP API Top 10, hopefully. I think I was at all of the API talks. So why does API security matter? Well, a lot of our apps have APIs. APIs, sometimes we try and secure them by putting stuff in front of them. Sometimes those APIs talk to other APIs. Sometimes there's not even a user. It's just APIs talking to APIs in our environment. And APIs are everywhere. They're hidden behind our mobile apps, like your mobile app's talking to an API, your website's talking to an API. There's APIs throughout your organization. There's microservices which just multiply a number and return the result. And they're everywhere. There might be critical functionality, there might be sensitive data that they store and return, and there might be undocumented endpoints. And so that's really the problem, is sprawl and sensitivity. So I forgot to start my timer. So I think I have 40 minutes left. We'll find out. So let's go into what is GraphQL. So GraphQL was a Facebook invention, and unlike their main website, it's not trash. Essentially, it's a way of querying an API and returning a nested structure of JSON. So you write a schema for your API, so defining what a project is and what its types are, very familiar. Then you use their syntax for doing queries. I've got an echo. Queries and specifying what data you want, and in here you'll put which fields out of the schema you want. And then the GraphQL server will return you a nice, easy to consume JSON object with just the stuff that you've asked for. There's three types of operations. Queries are for reading, mutations are for writing or performing actions or changing state, and then subscriptions are when the server can push notifications. I think I hardly ever see subscriptions, and then probably 10% mutations, and then lots of queries. So what are the benefits of GraphQL? Well, one of the main benefits is it's a good entry point into your organization's APIs. So it's essentially a proxy sitting in front of all your APIs, databases, and systems behind it. You can do fancy federation stuff, you can make it a giant monolith, but you can essentially have one way into your organization with a consistent query syntax. So instead of having to look up the documentation for a particular microservice, you can just read the API documentation. A nice thing about GraphQL is because it's at that middle layer, you can have a nice stable schema and then gradually change your backend services, database structure, and as long as you keep to that contract, your applications will keep working. And a really nice thing is that websites and other clients can request just the data they want. So In my soccer site, there's listings that you can browse. They have authors. The authors have listings. The listings have authors. But maybe I just want the name of an author, so I don't need to go all the way down that tree every time I do a query. And the other thing is that you can also fetch wide, so you can grab lots of things, one response from the server, rather than a very chatty, mobile app that does lots of calls. You can say, I want all these things. The server does all the chattiness, gives you back one chunk. GraphQL, because it's like a consistent format, it makes it a little bit easier to do caching for performance. And the schema is nice and self-documenting, pros and a con. Animation, interesting. Okay, so let's have a look at our site. So as I said, I've got a GraphQL server, and I'm using Apollo, which comes with this cool Studio Sandbox thing, and that basically lets you navigate through your API schema. It shows the documentation for the fields, the queries, the fields. So here's a listing query. It fetches a listing. You can jump across and actually run the query. So if I want to run this, there's that query syntax. So listing is what I'm requesting, and then I can choose which fields I want. And then I can run that query. And oops, I forgot to give a number. You can provide parameters, and then you get back the data you wanted. And like I was saying, if there's some data you don't want, the server only needs to send you the data that you ask for. So pretty cool. What was the other thing I was going to talk about? Oh, yeah. So like I was saying, it was self-documenting. And if you go in here, you can actually see the schema. So here's the schema that I've defined on my application server being sent to the browser so that this application can build the UI for it. And you can see all the documentation's in there. And there's another cool tool, GraphQL Voyager. So this lets you just look at the structure of your API. So it's got a few example ones. So if we look at GitHub's, so GitHub have quite a simple API, and you can jump into bits of it, and let's see, you can look at a hard ref pushed event, and it can return an actor, which is a user, and then you can go and look at, oh, that didn't zoom very well, maybe because I zoomed in, and then go and look at a user and navigate around your graph like that. And you can also paste in your own schema. So soccer.net, it's quite a complicated app, and so I think you'll see the schema is obviously worthy of the investment I've put into the system. And queries can have listings, you can query listings or authors, and they can reference each other. Okay, cool, great demo. Okay, continue. So OWASP Top 10 API Security Risks 2023. I say it's a set of the top 10 risks as defined by industry experts and a little bit of quantitative data to try and find the security risks that are really specific to APIs. So not the normal boring stuff that's in the regular top 10, because we've got the regular top 10, but stuff that's kind of API specific. So all the normal vulnerabilities still apply. So you'll still be able to have SQL injection. You'll still be able to have cross-site scripting or whatever. But these are the sort of API-specific ones. I'm going to run through some of them. And also I wanted to point out the cool cheat series on the OWASP site. There's a GraphQL cheat sheet on there as well. Slides will be available later. So here's the top 10. Rather than do it in numerical order, I'm going to do it in a randomized order. So here's a picture of an interaction between a client and a server. API sends a message. Pretty good. Right about now, you're wondering, how did I get my graphic art skills? And I learned them doing computer science. So who are you? The API has to decide who the user is, and how will it do it? So there's a few different options, might be username and password, client certificate if you're a masochist, API keys, JWT token if you're a hipster. And then the API can decide whether to let you in or not. So this is where we get to number 2, which is not doing that correctly. So things that might happen if your authentication's not working properly, you might let people access endpoints or operations without authenticating. You might be able to guess the credentials. They might be able to be brute forced. You might be using tokens or API keys that are not random or that aren't signed. So let's do a little demo of this. Oh, here's this site. Wow, how handy. It's like someone made a vulnerable site just for us. When the site loads, it's making requests to the GraphQL server. And I'm just being lazy and doing it in here, but you can see that there's a bearer header with what looks like a JWT token. Can anyone see anything wrong with this JWT token?
It looks like it's unsigned.
Yes, yeah. There's a full stop at the end of the sentence that's not supposed to be there. So if we go paste this into a JW token decoder, it's telling us that this token, the author of it, what a fool, has decided not to do any encryption or signing of the token. So you've got the payload, which is who the user is, user 1. The site has more users than 1, just in case you're thinking of investing. But I'm just focusing on that first user. There's 7. So we could forge this token, and we could change it. So let's do that. Do I have a handy 4G token tool? No, I don't. Sorry, I could just do this using like regular command line base 64. But I don't know, I just like using the decoder tab, so you'll just have to bear with me for a sec. So there's the token. So how JWT tokens work is the first bit before the first full stop is like what algorithm, and the second bit is the body of the token. So if we base 64 decode that, you can change the user to a different one and then re-encode it and then copy that back into our browser. And I happen to know that the token's stored in local storage because I remember what I did 2 days ago. And now we're logged in as a different user. And so I'm no longer matching. That's a shame, really, isn't it? Oh, well. So that's an example of, like, you know, a blob of encrypty kind of goop authentication stuff that's very easy to make a mistake with. There's other mistakes you could make with JWT tokens, but that's the easiest to demo. Okay, so next one. So what's another top 10? So your API might have multiple functions sitting on there. Is the user that we've just identified allowed to call that function? So are we using roles or capabilities or privileges or whatever to try and decide who is authorized? And so that's obviously another one. Oh, yeah, I won't just say that's another one because I'll say that 10 times. Okay, so here's a demo of authorization. But first, how would we even determine that there's functions that we can try out? So remember that I showed you the schema and how there's nice ways to browse it, either graphically or textually. Let's go have a look at our schema and see if there's any functionality that's not exposed through the UI. So you could get listings, authors, you can count how many people have viewed the site, you can log in, or the administrator can update users using an ID. Spoiler alert, that's an administrator function that we forgot to put a, if user equals administrator on. We'll come back to that. So that's how easy it is to introspect APIs. So even if the GUI's turned off, you can just send a GraphQL query to the GraphQL server saying, give me your schema. And so that's what this query is doing. And if I send that to my server, it's returning the schema object. So you can turn this off if you want to like hide stuff, but it's just a false sense of security. So I reckon just leave it on. It's better to actually just review the functions that you've got rather than try and hide them. Because people could still try and guess by entering random names. So just to show you how easy that is. So here I'm trying to guess what the next field of the user object would be because I don't have the schema. So I just type field name in. Oh, I get an error if it's not correct. And then depending on your options on the server, it'll say, did you mean? And then give you a list of other fields that you want to try. Or you can just do a binary search, kind of, I don't know, brute force, guessing field names. So, you know, nothing secret on the internet, apart from your sock preference. So, next one. So you're sending a message that's got an ID in it to the API, and that ID is a key into a database. Does the user have access to that ID? So not the function, but the actual object. And that's where, if I wasn't talking so much, I'd show you that you can pretend to be the administrator and just call that function with other people's IDs and change their first names. The next one is fields. So does the user who's currently authenticated, authorized, and allowed to access that object, are they allowed to read a particular field? Are they allowed to write a particular field? And this was a problem, I can't remember how many years ago, with Rails. There was a mass assignment bug, which was, you know, normally the object that you're sending to and from your web server has, you know, 5 fields in it. But if you stuck an extra couple of fields in, the server would happily accept them and update the database record. But there's a lot of variations on this. So it's called object property level authorization. So we had field, ID, and property. And can you know guess field names? We talked about that. So let's look at our site. So there was one thing we saw, which was when there was a user that I matched with. Who am I matched with? I'm going to do one that I know who I matched with. Dating is so complicated. I'm so glad I don't have to do this. So when I'm matched with Construction Craig, I see his private details. But when I'm not matched with him, I don't see them. So what if I ask for them for someone I'm not matched for? So I happen to know that that is the listings for home query that we want to run. And I'll ask for the author for that listing. And the hidden field is called description. So when I request it unauthenticated, I get null as the description for the author. I'll just log myself in by stealing my auth token. Okay, now that I'm logged in, I can see the description of the person that I'm matched with and their private information. But what if I try some other user? Oh, actually, I've requested all the users. So let's just go down and look at one of the other users. Oh, rats. So the server is sending back null, even though I'm asking for description of users that I haven't matched with. So it's actually implementing that field level authorization. I'm surprised as you are. Okay, so what about the impacts on your business? I actually drew that building. So what things can happen to your business when people abuse your API? Things like sending spam to support staff, reserving tickets on a concert website so no one else can get them for 5 minutes, exhausting the number of objects in your store, like thinking about the impacts a bit wider than your API itself. Oops. So yeah, that's more like a thought exercise than I can demo how you did that wrong in an API. For each business function, you need to do a bit of a threat model and think about what would the impact be on the business if bots were to do this. So if bots were to scrape all the listings on your dating website, could they publish their own dating website or dox people or whatever? You know, do you need to put rate limits in place or bot detection of some other sort? Okay, what if your API is calling other APIs? That's a fun thing to do, and that's what GraphQL does. Can an attacker change those requests? So we call this server-side request forgery, which is when the attacker gives some data to a service, and then when that makes further requests on, the attacker's data is incorporated into those requests in some unintended way. So there's bad things that can happen. A common one is seeing the AWS metadata endpoint 169. Whatever, because then you get AWS keys, but also you can probe the internal network of a server, change the path of requests, and essentially do whatever you want. There was an SSRF talk yesterday, but unfortunately I missed it. So apologies if you saw that, and I'm covering ground you've already seen. So, looking at my queue list. So the demonstration I have for server-side request forgery is not contrived at all, and it's actually one that I've seen before. But of course it is contrived because this is a talk. So when you get a listing, you get back listing details, and you'll see there's an ID and a description. And if you remember from our author, when we got back authors, there was also IDs and descriptions. So what if we can trick the GraphQL server, instead of fetching the listing endpoint, it attacked the author endpoint? And so what if I'm guessing that it's a REST API in the background, and it's going to go /1 on the end of the listings? What if I went up one level and then tried an author's endpoint and passed /1? Well, that was interesting. I still get back an object, but I'm not seeing the description. And that's actually because I have implemented security. Like I was saying, there's actually no security in the REST API. It's all done in GraphQL. But I pass this little flag to the REST API to say, this is yourself looking at it. And so now I've gone up one level, I've accessed the author's endpoint, I've gone to item 1, and then luckily the fields were named the same, so GraphQL has mapped those two together and returned a listing that contains the private author information. So that's actually a really, really common problem, and I think how it happens is probably not validating input very well. So in the place I do this, excuse my not awesome code. So which one was I doing? I was getting listings. I'm calling the API from GraphQL, and that is going to /listing with a listing API ID on the end. And you see it's a string, so I'm not enforcing that it's an integer. I'm not doing any bounds checks or anything like that. So essentially what the GraphQL server is doing is just doing a GET request to listing /1, and if I'm able to modify that to have something else in it, I don't know if curl's going to complain about that, then you can see it's actually doing a request against a different endpoint. So that's, I guess, path traversal form of server-side request forgery, but often you'll see other things like uploading files or passing URLs where you can probe an internal network. Okay, Ramandeep, how many minutes do I have left? while she's working that out. Okay, so do we know which APIs we even have? It's kind of not a technical vulnerability, it's a human vulnerability, but we've got lots of them, and we need to keep an inventory of all of them. And it's really common, 20, thanks. It's really common to have old APIs lying around, dev versions that are published on the internet, I don't know, acquisitions, things that aren't patched, things that were temporary for a hackathon or something, and you use real data because that's what hacking is. And you know, if you don't have a nice inventory of all your APIs, you might have a footprint that you don't know about. Okay, is the API configured and patched properly? Well, this is where it gets hard because cloud stuff is difficult and Terraform is horrible and CloudFormation doesn't let you comment, and all these terrible things make it really hard to actually configure things securely and make sure that they're getting patched. So you have my sympathy, but there's a category for you. Some things that are GraphQL specific, you know, you might have debug mode enabled, or that nice Explorer that I was using to navigate it. You might be exposing stack traces in your error messages. I think we saw that on some of my bad ones. You know, it's actually, in my error message, it's showing the internal URLs in my network, some of the actual errors, the stack traces. You know, not ideal. I mean, yeah, you don't want to tell people things they don't need to know. Okay, my example of this is, what if you had something sitting out on the internet with GraphQL in front of it, but you forgot to block the actual underlying API? So GraphQL is sitting on soccer.net, but if you go to port 2000, you can access the REST API. And that's a real bummer because the REST API has no security on it because I'm doing it all on the GraphQL layer. So just remember that if you're putting WAFs in front or CDNs or API gateways or load balancers, to make sure that your individual instances aren't accessible. And should we even trust the data that the APIs give us? So we're consuming APIs all the time, and we have a tendency to trust things that we get from our own APIs and our databases and just put that data onto the screen without sanitizing it. And when we're using third-party APIs, the same thing can happen. We need to remember to sanitize it. And are we accessing it over secure channels? Like, are we using HTTP instead of HTTPS? Yada, yada. Very standard. Does this API do heavy work? So I think this is the last one, because this one is kind of dear to my heart. So you've got this API that's doing a bunch of stuff to make it easier to write a React website. You just ask for data and it goes and finds it for you, assembles it all back into one document. So my soccer website, when it was displaying the listings on the homepage, it was querying listings. For every listing, it was finding the author. It was assembling all that and giving it back. But could I overwhelm the server by doing too many requests? And this is vulnerability 4, which is unrestricted resource consumption. And could there be a cost? Like, am I using lambdas that cost per invocation? Am I sending SMSs for 2-factor codes, 1-factor codes, whatever? And are there other costs that could be included? So I've got some examples to show you of the types of things you can do in GraphQL that you can't do in other APIs, which are kind of fun. So let's look at that listings for homepage endpoint. And that returns the data of a listing and then the data of an author. But authors are defined in my schema as having multiple listings. You know, they can advertise for whichever category of sock alignment they want, left, right, whatever. So they have listings. And then those listings probably have authors, right? So I need to drill into this. So otherwise I have to type. GUI's much better. So the listing has authors. The author has listings. Oh, the listings have authors. The authors have listings. And we can just keep going down. And this is the bit where you kind of go around in circles in GraphQL, which is that, you know, you're getting a hierarchical representation, like a JSON object, of a circular graph thingy. And so you can just keep navigating your way around that graph and getting bigger and bigger responses. So I can't even view this anymore, but it's getting really deep. Not the meaningful kind of deep, the other kind of deep. So that's one thing that could consume a lot of resources on our server. And this is an example of the n+1 problem, or 1 plus n problem. I don't know, it's an example of a problem where you've got a thing in your system, it's doing a single request. In this case, listing's actually doing L requests. L's happen to look like ones, so it still works. So it's getting all the listings, and then for every listing, it's getting the authors. So now we've got L times n, and then it's getting the listings again. So now we've got L, M, N, and this is combinatoric. This is multiplicative. This is bad, which is where the numbers get big really fast, because the way my API works is I get the listing, and then I've said, resolvers. Sorry, I get the listing, and then I've said, for every listing, if someone asks for the author, run this REST call. And then I've said for this author, if someone asks for the listings, run this REST call. And GraphQL is happily stitching all that together to give the client one response, so they only have to call once. But the server is doing a lot of work there. So yeah, n+1 or LMNOP. Other kind of bulk operations that can be performed. This one's called batching, so rather than going deep, you're going wide. So say you've got something that's a heavy query, like, I don't know, I don't use Facebook, displaying your friends or something like that, calling it hundreds of times in a single request to the server. And then that way, if the server's not doing caching, it'll be multiplying the number of requests. In my experience, most GraphQL servers seem to have batching turned off, which means you can't put an array of queries that you want to call. But you can just put multiple queries inside a query. So I'm doing the same query. Well, it's not actually, but I'm doing the same query and just saying, give me the authors, give me the authors, give me the authors, give me the authors. And that does the same thing as the previous batching example that you disabled for performance or security. Smuggling. So sometimes you think, okay, my GraphQL server's allowing this bad thing, I'm going to block it. And if you're in a security team, you'll be like, I don't want to touch the developer's code, that's scary. And I can confirm that my code is scary. How about I do something in the load balancer or the WAF or the CDN or some other layer, API gateway, to try and block this? So maybe I can block square brackets so they can't do batching, or maybe I can count the number of times they do a query. The problem is there's actually like 3 nested contexts of each request. There's a JSON body with a GraphQL query in it inside your request object. And because that's JSON, you can do all the standard JavaScript things to hide stuff. So you can, I don't know, put the same key twice, and maybe your API gateway will just check the first one. Seen that. You can JavaScript encode. This is a pretty simple one, but I've just replaced A and S, so that's authors. And so if it's a simple string match, you might get past it. Often the servers will support multiple ways of querying. So this GraphQL server, you can post the query as raw GraphQL query, or you can put it on the URL query string, or you can post it as JSON. Your application probably just uses one of these, but an attacker we'll probably try the other two. And even if you do manage to figure out a way to stop it in your WAF, which I don't think you will, the WAF only scans the first so many bytes of your request. So you just put a lot of white space at the beginning and then put your attack 8 kilobytes into the request body, and you can get past every signature in the WAF. 10 megabytes takes a few more white spaces. So I haven't covered everything. I'll give you a full list in a sec. But that's the API top 10. I'm pretty sure we went through all 10 of those in the wrong order because it made the diagram work. And hopefully you can see that there is some stuff there that's not in the normal top 10 and that you don't see in client-side applications. We've dug a little bit into GraphQL. So let's look at, not finished the talk yet, 7 more minutes maybe. We've dug a bit, let's look at some GraphQL security stats. So it's a relatively new area, and I happen to be familiar with one company called Escape, and they've done this survey of 160 different public APIs. They just crawled across it with the scanner and found 4,400 secrets, including 2 credit cards, a bunch of passwords, returned from public GraphQL APIs without authentication. And they broke down that API top 10, looking at what the most common issues they found were. And there's a bunch of the normal stuff you'd see, but then this unrestricted resource consumption, which is the ability to just put load on the server by doing deep, wide queries. The link for that will be in the slide. And there's a bunch of other vulnerabilities that you can have in GraphQL, and I haven't been able to cover all of them. So you can take fragments of queries and reuse them in lots of places to make your request small but the response huge. You can put aliases in your query so that instead of saying get listings for homepage, you just say X everywhere to make it harder for people to see what you're querying when they look at it. There's cyclic queries, we showed that. Debug mode, we showed that. Duplicate fields, sometimes there's, that's kind of self-explanatory. Introspection is when you can look at the schema. SSRF we looked at. Not checking for integers. There's a ton of things. This is the list, I think, that's mostly GraphQL specific, although you will see some of the stuff in your other API types as well. So yeah, just fix all those. Not quite finished yet, so don't pack up, because I know that as soon as you get to the last slide, everyone's like, lunchtime. Is it lunchtime? No, morning tea time. I didn't sleep much. Okay, so unfortunately, it is hard to secure your GraphQL server, and some of the traditional tools you might use don't work. Like on a regular web server, you might be like, oh, there's an admin REST API. We'll just edit the Apache config and block /admin, solved. In GraphQL, everything's under one URL, which is /GraphQL, and it's the post body that determines the operation. So you don't get that simplicity. I showed you a bunch of bypasses, but there's more, so it's hard to check for strings in the request body. It's hard to rate limit. If you rate limit /GraphQL using traditional WAF rate limiting, then you're going to rate limit everything. And things like API gateways are expensive, and some of them have limited protection for GraphQL. They might validate that the schema is correct or allow you to lock off bits of the schema, but they might be able to be bypassed in other ways. So really the takeaway at the end of this is it's actually the GraphQL server that you have to harden, which means that you have to dig into, what is it? Index dot, this bit, where you start up the Apollo server or whatever your server is and what options you pass to it. And so it's quite opaque, hard to do. painful. And it's not foolproof because the requests are getting all the way to your API. You're not blocking them early. So if there's a request flood or something like that, it's getting all the way to the API. Then the API is running the authorization logic, kicking the user out. There is some middleware that can help. I've got some links here. So 3 of them are MIT licensed. So GraphQL Shield lets you put like authorization policies in place, maybe even block certain operations. Armor hardens your GraphQL configuration, just like sets a bunch of options that you'd have to figure out yourself, like how deep can the query go, can you use aliases, that sort of thing. GraphQL Voyager was the cool tool that did the diagram of how awesome my API was. So the links for these are all in the slides. You just need to click on there, but they were too big. It ruined the aesthetics of the black and white slide. There's a scanner, which you have to pay for them. There is open source command line scanners as well. And inside Burp, you can actually do GraphQL stuff, run attacks against GraphQL, and some of the other scanners do as well. Surprisingly, the vulnerability scanners are pretty weak when it comes to GraphQL vulnerability scanning. Yeah, that's kind of a problem. So often they'll say, just enter your GraphQL endpoint. And that's all you get. Okay, so I finished the talk. But before we finish, we need to talk about my new business venture. So 12 lucky people in the audience are already on their SOC dating journey. And I wish you all the best. Please sign up to the site, post a testimonial. I'm also looking for investors. So we've valued the company at $45 million. Now, this is not based on user count, which is 7, but on potential. So please fund us if you're interested in this. And that's the end of the talk. Thank you for attending.
Do we have any questions?
Do we have time for questions?
Sorry, hello. First of all, I just want to say thank you for the wonderful talk, and second of all, thank you for the great example as well. It's really funny. The question I wanted to ask, though, is that a common issue in GraphQL is introspection, where unauthorized users are able to see a schema and they're able to query, and they know of things that they shouldn't usually be able to query for. And it's quite a big problem, and I'm just wondering, when introspection is disabled, when introspection is disabled, what tactics would someone usually do in order to find what to query for in GraphQL?
Yeah, so I understand the question, and thanks for saying it into the mic so I don't have to try and summarize it. Phew. But I just need to pad this out while I think of an answer. No, just kidding. Yeah, turning off introspection, I think, is like a false sense of security. You think you're hiding stuff from attackers, but the endpoint's still exposed. I think it's defense in depth. It doesn't hurt, but people can. I think there's like a dorking tool that'll try a bunch of common query names and see if any of them work. There's another tool that looks at the suggested fields, like if you type over the field name and say try these other ones, and then it'll build up the schema. So it's very similar to SQL Map, if you've ever done that for a database. And there's other ways that your schema is exposed as well, like the JavaScript of your website probably has GQL queries in it for administrators and regular users. Is that a good answer?
Yeah, thank you.
Okay, cool.
Yeah, just commenting on that further as well. It's actually really interesting seeing how much pushback. There's actually a lot of internal debate even within, so I work for Bastion Security, and I debate with my colleagues about this one all the time. But then they look at its SOAP interface and they're like, oh, the WSDL's there, that's just kind of part of it. And it's the exact same thing, which it just finds it. There'll be a, a what's the REST version of it? The Open API Swagger documents. And they're not so stressed about that either, but this one they're really fussed about. So it can be a bit of an interesting debate about whether it is a good thing or a bad thing. I think for private APIs where it's like kind of designed to be, you're not supposed to expose all of it to the public, maybe it's worth turning it off. But like again, like it is, it's a defense in depth mechanism, but it's not something you should rely on. For public stuff, yeah, leave it on. It's probably all good. My question going into this though, is there a way that you should or shouldn't be filtering what gets exposed through the introspection API? I don't know whether it's a standard or not. I've certainly seen some things part of it, but like depending on whether you're logged in as an admin or not, you get a different introspection API.
I haven't seen that. That sounds, I don't know,
It's
interesting.
interesting to me. I haven't seen any documentation on it, so yeah.
Okay. I think we need to leave. Is that right? Yeah. I'll chat with you later.
Quickly answer, just no time, literally no time.
Yep.
Yeah. All right. Thank you so much, Kirk, for your lovely talk.
Thank you.